Okay, let's start numerical 3.22. So you have to consider a spherical polar coordinate system, and here you find the center of mass of this uniform solid hemisphere. So what is given there? That actually the xy plane, which is the flat face, okay, with center at its origin. So this is the value for volume, which is already given, r squared dr sine theta d theta d phi, which is the azimuthal angle. Okay, now first you have to consider the formula for center of mass, and this is the density, which is equals to this mass per unit volume. Now you have to arrange it, so you will get the value of mass, which is the density, into volume. Further, you can see the volume of the solid hemisphere, which is already given, so you can prove it by yourself, okay, which can be shown in the diagram. So here's the diagram of the hemisphere, okay, and this is the volume, which is 2 or 3 pi r cube, okay. And again, let the mass density formula, which is the simplest formula, now you have to put the value 2 or 3 pi r cube instead of this volume, okay. And this is the value after putting this is the value final, okay. And further, let this formula again, and you have to put the dm value, which is equals to this value. We have already proved it, okay. So further you can see, now since the object is symmetric about the z-axis, so what we can say that the xy plane is at 0. So the center of mass are 0 at xy plane. So the center of mass must lie in the z-axis. It must be lied, okay. So here you can see this is a formula, and in order to select the coordinate, which is z, so you have to put z instead of r. It's obvious a distance, okay. You can show with any letter. And further you can see, using spherical polar coordinates, z is equals to this r cos theta. When we talk about some components of the hemisphere, so you will get the along z r cos theta, okay. Now further you can see, now you have to put the values in the center of mass formula, and value of the volume, which is given in question already. So this is the value. Now you have to multiply the same quantity, so r cube, and the remaining terms remain same. So you have to separate it, apply integral on separate entities, okay. And this is the azimuthal angle, which is from 0 to 2 pi, and further the r cube, this is from 0 to capital R, which is the radius. This is the radial component, okay. And further you can see this is the trigonometric identities, okay. So you can put the value of theta, which is limited 0 to pi. So after applying integration, you will get these terms. So already you know very well that this is the limited values, okay. Now further you can see, after putting the limited values, okay, you will get what? You will get the values. These values we will get after integrating. So you can do it by yourself. It's simple, okay. There's nothing new in this question. Okay, further you can see what's going on. Now further you can see, after putting values, we will get this 2 pi r4 by 4 and a half, okay. And after cancelling the same terms, you will get only density pi r4 for m, which is in ratio. This is the value for center of mass, and now you have to put the value of m, which we have already proved, okay. This is the value of m. Now you have to put it instead of this m. This is the mass, which is equals to density into volume, and we have the hemisphere volume, which is 2 over 3 pi r cube. Okay, now further you can see what's going on here. Now this is the formula, this is the value we will get already, and now we have to cancel the terms, arrange the terms, and you will get the center of mass of hemisphere, which lies along z-axis. Okay, so this is the term 3 over 8 r. So this is the 3 over 8th part of the center of mass, which lies on z-axis. The center of mass I already have, I said that it must be lie along z-axis, so there is no need to say that we don't need any xy component. This the center of mass is along xy 0. So the center of mass of the uniform solid hemisphere lies at a distance of 3 r over 8. Okay, from the xy plane along the z-axis, the center of mass is located at these terms. So x and y terms are 0, and what we got, the center of mass lie along z-axis. So this is all about from my side. If you have any question regarding this, you can ask me. Thank you so much.